Good evening. Welcome to Science on Tap. My name is Andrew Lyon. I am the Dean of the Schmid College of Science and Technology at Chapman. And this is an event we hold pretty much every month where we try to discuss some interesting things in the world of science and technology and hopefully get awesome questions from the audience. Okay, so in the second half of this event, you all are the stars, and we'll talk about how that's going to happen in a little bit. But first, please join me in a big round of applause for Chapman Crafted for hosting us. We greatly appreciate the space and their hospitality and obviously the awesome beer. So the way this works is we will talk about some cool stuff, and we have some really interesting thought leaders in science and technology with us tonight who are going to tell you some amazing things about what they're doing at Chapman University. That's going to take up about the first 20 minutes of the event, where you will listen in rapt attention to all of the things we have to say. You will be coming up during that time, you'll be coming up with some awesome questions. There are note cards on your tables for you to write down those questions. So during a 10-minute intermission, please write down awesome questions, go get a new beer. And then in the last 20, we'll have an opportunity to ask questions that you have posed. The important thing to note is if your question is asked, that wins you a beer ticket. So there is money on the line, as it were, for asking awesome, inspired questions. Okay, so tonight's theme is a program that exists at Chapman University that was started in the Schmid College of Science and Technology called the Grand Challenges Initiative. It's a very grand name. Professor Goldsmith, Greg Goldsmith at the end, is the director of that program and also a professor of biological sciences at Chapman. And I'm going to ask him first to give a little bit of an introduction to the program and to himself to set the stage for the evening. Greg?
Thanks, Andrew. Evening, thanks for coming out. My name is Greg Goldsmith. I'm an assistant professor of biology, and I study tropical forests. But actually what I am really passionate about is how we use the sciences to solve really hard problems. The Grand Challenges Initiative is about solving so-called grand challenges, these intractable, complex, wicked problems that face society, and we're trying to solve them from the perspective of science, technology, engineering, and mathematics. But the foundation of the program is a little bit different. If I ask you all to think about the most formative experiences that you had in your school career, very few of you are going to raise your hands and say, Dr. Goldsmith, the 700-person lecture that I had in Sociology 101 on Thursday at 7:30 a.m. changed my life. Some of you may. We should talk afterwards. Many of you will say things like, Dr. Goldsmith, it was organic chemistry lab where we synthesized whatever compound, or it was getting connected to an external mentor that ended up giving me a summer internship that changed the course of my career. It is about experiences where you got your hands dirty doing things. And that's what this program is about. It's about making sure that students from day one at Chapman in the sciences get their hands dirty, try to solve hard problems, and make mistakes, and learn as they do it. So those problems range from everything from groups of students that are working together to try to use artificial intelligence to secure voting systems, teams of students that are thinking about how we would do better to manage and prevent the devastating wildfires that we've had recently, all the way to teams that are trying to cure neurodegenerative brain disorders. And the expectation is not necessarily that our first year 18-year-old students are going to achieve these amazing goals, although I always tell them that if they do, I will buy them dinner. It is that, again, from day one at Chapman, we want them to do science and get their hands dirty and make mistakes and learn something and maybe even have a little bit of fun doing it.
Thanks, Greg. So it's a really complicated program because these are complicated challenges. And we have 4 students with us this evening that are working each on very, very different challenges. They're representatives from 4 different groups. And we'll have them introduce themselves and talk a little bit about their challenges, and then we'll dig a little bit deeper into their specific experiences.
Hi, so I'm Caitlin Abdo. I'm a biochemistry major, and my project is a game to improve social skills of children on the spectrum. So,
my name's Corey. I'm a computer science major, and my group's working on rapid supply deployment in post-earthquake and post-hurricane natural disaster situations.
Hi, my name is Mary Ratman, and I'm a biology major, and my project is testing to see if tyrosine, in fact, increases human focus, and if the brain was reverse engineered, if that would help our human intelligence.
Hi, my name is Alex Drevis, and I'm looking at optimizing photosynthesis.
Cool. So very, very different challenges, different majors, and one of the themes that happens in this program is the students are in these teams of 4, 5, 6 students, and the teams are interdisciplinary. So they're looking at these challenges from very, very different angles and working together to come up with creative solutions. The overall theme for this evening, and I want all of you to think, again, as Professor Goldsmith challenged you to think about the formative experiences that you had when you were all in school, and think about the following question. Is Dr. Goldsmith right? Is this really different? Is this really useful, right? Or is this something that, can we achieve the same outcomes via a different approach? Digging a little bit more deeply into the student experiences, however, I think is going to illustrate how the program is indeed different. So I'm going to answer the question for you, and then you can argue with me later. Starting off with that, Caitlin, you talked about developing an app or a game that helps students on the spectrum or helps learners on the spectrum have appropriate human interactions. Can you talk a little bit about how digging into that problem has personal meaning for you and why you chose that challenge?
yeah, so I have a brother. He's 12 years old, and he was diagnosed with autism when he was about 5 years old. So for me, choosing this challenge was a no-brainer. I really, even though it can be hard, you know, it can be emotional because it's your little brother, but I really enjoy doing it, and I know just by if it works great, and when it's completed, it could help a lot of people, including my brother. So yeah, and I think it's a perfect way to do what you want and explore a field that you would never explore. Being a biochem major, I don't think I would have ever made an app, ever. So I thought it was really unique that I got to do what I wanted to do, even though it doesn't exactly line up with my career path. And it allows me to impact my brother and so many other people who may not have the resources to benefit from, you know, therapy or anything like that. So, yeah.
Thank you. So, you know, this is a theme, right? Students get to bring their personal experience to inform how they approach challenges, which is something that I think is a little bit unique in the landscape of higher education. On the flip side, Corey, you have had an interesting experience. So you're a sophomore, correct? And so you've had what I understand is somewhat a winding path to where you are right now. Could you talk a little bit about that?
Sure. So the first project that our group started working on was the transportation sector and how do we make that greener. And so we posed the idea of road rationing, and that wasn't all too inspiring to our group. So from that point, I said, okay, how do I work together with these other students and really form a well-functioning group and we're working on something that everybody's interested in. So from there, I said, okay, well, lots of people are interested in drones. That's a new up-and-coming technology. So why don't we use a drone to do something useful? And so then we posed the idea of, okay, well, maybe we could deliver supplies to people in need with drones. And that's how we funneled into the idea of earthquake response with drones and rapid supply delivery. So, yeah.
So I understand that Dr. Goldsmith is a little bit unkind, and he stipulated that if your group was going to do this, you had to do something. What do you have to do?
So we had to build the drone ourselves. That was the one caveat. We could not buy one. So it's still in progress, but hopefully it'll be done by the end of the semester.
Lots of 3D printing. Lots of 3D printing. Mary, you and your team kind of took the, the world is my oyster type of approach to your challenge. So can you talk a little bit about how the program has opened up avenues for you and allowed you to use all of the resources available to you at Chapman in order to tackle your challenge?
Yeah, so at the end of last semester, my group and I were trying to figure out how we were going to test this amino acid tyrosine, which we had been reading about, had all these really cool and scientifically proven, well, theoretically, it could increase the activity of ATP in the cells and make us more productive, make our neurons more productive. And so we were trying to find a lab at an institution nearby that could, or someone to look at our project and see something in it and want to take us up. And we reached out to a lot of people, a lot of bigger institutions, and didn't really hear back. And so we tried the avenues within Chapman, and we found a connection with a neuropharmacologist at the graduate research campus in Irvine, Rinker, and we met with him, and he has allowed us to use his lab space and has really taken us under his wing. And having that space and learning so much more about how you apply the research to the reading to actual physical research has really allowed our group to just see what science is and using the scientific method, and it's just been a really cool development, and it just feels like this is what our careers have drawn us to do, and it's really incentivizing to keep going and keep seeing what we can do if all of this research keeps pushing us to the future. So, yeah.
Thanks. And so again, another theme is there's agency given to the students, right? So the students now are challenged to say, okay, here's the problem you're working on, go figure out how to solve it. And it's, I frequently talk about how college is supervised adulting, right? So it's your first experience going out and trying to figure out how to navigate the world that's much more complex than the world was when you were in high school. And so this is an example of that, of a student and her group figuring out exactly how to leverage all of the resources that are there for the taking. It's just not, there's no rule book on how to access them necessarily. So Alex, you've actually done similar types of things, but you've looked beyond Chapman's campus to figure out how to broaden your horizon. And that's one of the themes, again, of the Grand Challenges initiative is building professional networks, et cetera. So how can you talk a little bit about what your team has done?
Yeah, so my team right now is more focused on determining the cellular process that basically controls water foliar uptake in the epidermal surfaces of leaves. And that's translated to an internship with Dr. Goldsmith working in his lab, which has been amazing, but that's also introduced to me so many skills that I've been working on in building, such as team building, teamwork, just asking questions and wanting answers. And that's driven me through the networking event that Dr. Goldsmith and the GCI network event hosted, where I actually met Steve Malish, and we basically discussed a lot there. He is the COO of a biotech company here in Orange called Fusion Biotech, where they basically make diagnostic instruments for biomedical companies. And that basically drove us to have a good connection. They invited me to their own networking event with other biomedical companies, where I met more researchers and everything like that. And I now have the opportunity to go have lunch with him later in December, and I'm really looking forward to that.
So again, this is something that Greg and his team work diligently on, and making sure that the student experience is now informed by external mentors or external thought leaders who come in, help mentor the student teams in how to attack their problems using basically their own world experience or own life experience from their industry. And it also helps the students build their first professional network. So how do you start navigating your career before you necessarily even know what your career is going to be, right? And that's a really enabling set of skills I think we probably all are aware. So those were some cool vignettes, okay? You've heard some amazing students talk about the cool things that they're doing. And remember, these are students who are doing this program as part of their first 2 years at Chapman, okay? So they're not seniors looking for their first job. These are students who are new to Chapman and have taken this on as an early part of their experience. The question that I posed at the beginning is, Dr. Goldsmith correct? Is this unique? And I think it is, right? But what we want to hear now is from all of you in terms of how you might view this program, what questions you might have about how it works in more of a nuts and bolts fashion, or maybe what our aspirations are. And also, most importantly, I want to know what your next beer choice is, okay? So we will pause for about 10 minutes. Please use the note cards and pens in front of you to write down cool questions, and we'll reconvene and ask those questions after the break. Thank you. Good job. All right, and we're back. Please listen carefully. If we ask your question, raise your hand, be proud, and you will get the magic beer ticket. So, Greg and I are going to take turns asking some of these questions. We're going to start off by thinking a little bit kind of big picture. And this is very much kind of an educator type question to ask. The question is, how will GCI self-assess and how will we know we're achieving our goals? We didn't even say what our real goals were, but
we're supposed to have goals?
Given that we have goals, we do have goals, how will we assess that? So first of all, who asked that question? Robert? I see you over there. Raise your hand so we know where the ticket goes. Thank you, Robert.
Okay,
Greg,
so
how do we assess?
how do we assess? There are actually objectives that we're trying to meet, and those objectives have to do with things like critical thinking and problem solving and communication and teamwork. And my goal as the director of the program is to not reinvent the wheel. What we do is we go and we look at the education research and we figure out what it tells us about what works and what doesn't. And we build off of that. And so there's a lot of really smart people that have thought really hard about how to do these types of projects. This project-based learning is what we're doing. And the foundation of the program is to use what other people have discovered about education. Then we use all different forms of assessment. So actually right now we're in the middle of a multi-year study where we are assessing how students' scientific literacy skills change over time as a function of participating. We're also in the midst of what I am thinking of as our own grand challenge, which is to figure out how to teach teamwork effectively. How do you teach people how to work together? Hint, it actually turns out to be very, very difficult. Where does the best literature come from? It's all over the place. But we are reading as broadly as the US military all the way to sports psychology. So we're devising a bunch of assessments for that in and of itself. So all of our different objectives as a program have different assessments to figure out whether students are getting what we want them to get out of the program.
Thanks, Greg. So, Greg, you have in your hand some awesome questions that are team specific. Do you want to address some of those?
I do. This first question is for Mary's team, and it is, how does tyrosine differ from Adderall? What parts of the brain does tyrosine affect, and what are the side effects? This person's already thinking about the side effects from their productivity drugs. Who asked this question? Yes. All right, you get the drink tickets coming over here. Mary, how does tyrosine differ from Adderall?
Yeah, I'm sorry.
So what we've been looking at, so tyrosine is an amino acid, and basically what we've been focusing on is how Adderall, our initial question was kind of that Adderall has some really bad effects on the heart, especially. As we've been noticing that a lot of college students and even high school students use Adderall to study, and it abuse it really, and it actually is really addictive and has a lot of addictive properties, and it has a lot of other health complications like damaging your heart over time. And so we were looking at something more natural to introduce, and tyrosine is a naturally occurring amino acid, and basically both of them stimulate dopamine in the brain. So kind of another part of the question was the side effect is that it's producing dopamine, which is tied to helping you focus and helping you stay focused for a longer period of time, to where we can, if this was, our overall challenge is to reverse engineer the brain. So if this was present in the brain at higher concentrations, then it would overall help our intelligence because we can focus for longer periods of time. What was the other part of that question?
Any known side effects?
Of tyrosine, we haven't found anything that's negative. Everything seems to be, because it's naturally occurring, it seems to be pretty, the whole advantage of using it is that it's not leading to other health complications, and it's even tied to alleviating symptoms of schizophrenia. So a lot of the pathways we went down and looking at, and methamphetamine, a ton of other drugs that stimulate dopamine or stimulants, is that a lot of paths lead back to schizophrenia. And so kind of we've noticed that this helps promote focus, but also alleviates other health complications.
So I'm going to throw Dr. Goldsmith under the bus right now. Yeah. You know what's coming, don't you? So the reverse engineer the brain grand challenge is one that I put on the original list for the program. And Greg came to me, months ago and said, I'm tired of this challenge. The students don't know what to do with it. We're eliminating it from the list. We shouldn't eliminate reverse engineer the brain from the list, Greg. Look at the awesomeness that has resulted.
Let the record show, cameras are rolling, that it is still on the list. It's a very, reverse engineering the brain, as soon as you poke a tiny bit at this challenge, you realize that our knowledge of how the brain functions is so limited. And the people that are working on it have devoted years and years and years and years of their life to just thinking about this one question and one tiny aspect of it. And now we are asking our first-year students to go after it.
And awesomeness results. So, Greg, going back to the big picture of how we operate this program, so the question is, are the various projects going to have their efforts published or recorded somewhere for reference by the public and future students? Who asked this question? Over here in the corner. So how do we disseminate these results, Greg?
Okay, so the projects take on lots of different forms, and the final projects that students do could be anything from a report to a website to a drone and all things in between. But I can tell you that I spent about 2 hours today going through something called the Institutional Review Board, which is the process that we have to go through as researchers to ensure that we're doing research ethically, because we have a team that is actually engaging in biomedical research right now, and they want to publish their results in a peer-reviewed setting to make it public so that others can benefit. And so one manifestation could be as part of the scientific record in the peer-reviewed literature. Another group that worked on issues around homelessness in the greater Los Angeles area has a website up where they've used geographic information systems, GIS, to actually create maps of where homeless services are. That's another one that comes to mind. So we're young. Andrew hasn't mentioned yet, but this is our second full year of the program. We're up to full speed. We have 460 students and 78 teams. And we haven't figured everything out yet. And one of those things is how we're going to consistently create the space for others to find new value from the information that students are generating.
Will it be available to, say, future students to follow up on some initiated projects that these folks are starting?
Yes. So the answer to that is we are slowly starting to assemble the final projects with the idea that we wouldn't necessarily want students to reinvent the wheel. Now, I am forcing Corey to make a drone, which has been done before. But in general, I think it would be great if student teams could build off of other student teams. That would be really exciting for me.
And sometimes dissemination takes on really interesting faces. So a few years ago, I was piloting the curriculum for this in a very small setting, not the massive setting. How many students are in GCI right now? 460 students are in this program right now, right? So back when I was teaching one section of 15 students, trying to figure out how this all worked, I had a team who was working on developing essentially a Fitbit that did much, much more than a Fitbit that actually predicted critical heart events or critical cardiac events. And they decided that they wanted to put their science and business plan to the test to see if they created a company around their ideas, a fictional company, whether it would fool people. So they created a website that was very slick, really looked like a legitimate company that you could sign up for to buy their device and sign up for their genetic testing service. And it was very, very impressive. I passed it around to a series of people who all admitted that if they saw this, they would not hesitate to click on the buy now button, which wasn't functional. They didn't link it to their PayPal account or anything like that. So sometimes dissemination takes on a different form where they're really just saying, how well did we do? And that's an interesting way of assessing their own particular project. Greg.
Okay, I'm going to throw this. This is a question that could go to all four, but I'm going to throw it to Alex. Alex, can you talk about your experiences with working in a team setting, and are there lessons that you have learned about what makes effective teams? Who asked this question? Oh.
Dr. Barry.
Your instructor, Dr. Barry, asked this question. Huh, suspicious.
So I've generally learned that teamwork is hard. Shouldn't have taken me this long to figure that out, but it did. More specifically, finding motivation, not just in yourself, but everyone you're working with, everyone around you. That definitely plays a big part into it. The exact project that I was working on this semester started with some of the skills that I learned over the summer, working with Dr. Goldsmith. And so I had a little bit more of an advanced condition of what we were doing. and that basically led me to be more of a team leader for my group, teaching them how to use different devices and stuff, working in the lab, and to find the exact motivation that I had with my love of plants in other people, and for some reason that's hard to find. But yeah, basically what I learned is that everything is not going to get done right the first time. To expect failure instead of wanting people to succeed all the time, and to set deadlines for other people 2 weeks ahead of when they're normally due.
That is a critical life lesson. Yeah. When you're the dean, it's a month. Greg, let's talk a little bit about how the students can take what they're working on and turn it into something even grander, like, can students turn their projects into a senior level capstone? And if so, how much independence does each student have over the project? Who asked this question? Over here. Student with a vested interest in, can I turn this into a capstone project?
I'm already a senior.
Yeah, when the program was originally conceived, we were actually thinking about it. Andrew was thinking about it as a 4-year experience, and we're at 2 years right now, which is at 460 students. I'm okay with that right now, but I think one thing that we're really excited about are projects that can transition into capstone, that can transition into other existing resources on campus. We have a Center for Entrepreneurship on campus. I see, waiting in the wings, I see 2 projects in particular that I think have actual promise for taking the next step. I'm not going to give those away for fear of someone in the room capitalizing on this set of ideas. But I think we're excited to see students either continue as teams, or one really cool thing at Chapman is that there are multiple different ways that students can get independent research credits. So let's say that there was just one really passionate student that wanted to carry the idea forward. We've got mechanisms in place for students to do independent research with a professor. Oh, yeah,
It's your job.
I'll keep talking. Okay, so this question is going to Corey. It says, Corey, have you had a chance to tour a disaster site to see how they function and understand their needs?
Who asked that question? Who asked about disaster site tours? That person has departed. Who wants that free drink? No, I'm sorry.
I have not yet. I've read a lot of peer-reviewed papers on disaster-ridden areas, but I think that would definitely be a cool opportunity for me to take advantage of. And
We actually, for what it's worth, when this is a little known story because it didn't come to fruition, but when there was a couple of major hurricanes, particularly Harvey, last year, we did make a bunch of phone calls to see if we could get students in on the ground because we had a bunch of student groups working on this. We have 1 or 2 student groups, I think right now. I'm having trouble keeping track of all 78 working on fire as a form of natural disaster. So we've obviously had some very severe incidents recently. So I think any time that we can put students either with external mentors who have experience in that field or actually on the ground, I'm excited to do that. And if you're sitting in the audience and you think, I have those types of connections, come see me and I'll buy you a beer.
So this question is explicitly written for Dr. Goldsmith because it says, Dr. Goldsmith, these topics require multi-talent. Are the teams interdisciplinary? How many on a team? And the duration of the project? We've already addressed a little bit about, but maybe you can elaborate a little bit.
Yeah.
Who asked that question? I'm sorry. Here, right here.
Yeah, it's a great question. So I think Andrew and I are of the philosophy that many, many, many smart people have worked on a lot of these really hard problems, and that it's going to take a diversity of disciplines and approaches to find transformative breakthroughs. And so we're really excited about having students from lots of different disciplines interact with one another on teams. And we are, I think we're at roughly, there's roughly 80 different majors on campus. And we have had students, I think, from 50 of the 80 majors now. So that includes most of the majors in performing arts, Dodge College, dance. If you can think of it, we've basically had those majors participating, and I'm excited both about the disciplinary majors that come in and participate in groups, as well as the diversity of experiences that our students bring to bear, because our students come from different countries, because they come from different cultural backgrounds, because they've had different life experiences. And I think that the way that they ask questions and think about solving problems, although we are teaching them particular methods to do that, they will always put their own flavor on that. And that's really important to me. I think that's how we're going to get past the wickedness of a lot of these issues. And I can give you, there was another question that was asked about whether I have any particular examples of students from different disciplines that have done interesting things. There's I'm thinking of a couple of students right now that are working. They're from the arts, and they are solving their grand challenge by generating a children's book. They're illustrating it right now. So we'll see what comes of that. That final project is due in 14 days if you're in the room. Okay, let's see. This is now back to me. Does Caitlin have questions? Oh yeah.
Caitlin has questions.
Let's hand it to.
I'll ask this question, Greg. We've got time for one question for you, Caitlin. You can't hog all the questions. So the question here is, Caitlin, are you collaborating with experts in early childhood development and/or mental health? And if not, how do you ensure that your work aligns with the best practices in current research? Who asked that question?
So yeah, we work really closely with Dr. Luann Boyd. She's a faculty member here who works in MLAT. She actually specializes in exactly what our app is, human-computer interactions with specifically people on the spectrum. She's had 30 plus years of experience in the autism field, and she just recently got her Ph.D. in human-computer interactions. So yeah, we're really lucky to be working with her. I met her about a year ago, and I say it was fate that we just happened to cross paths, that my project ended up being this. And she actually wrote a book that is the book version of our app, and I had no idea until like a couple weeks ago. So yeah, we work really closely with Dr. Luann Boyd, and I do research in MLAT as well. So yeah, I have a lot of experience with this. So.
And just so you know, the alphabet soup that is Chapman University, MLAT is the Machine Learning and Assistive Technologies Laboratory, which is a group of computer scientists at Chapman who work on different ways of bringing technology to bear to address particular people with neurodiversity challenges, et cetera. Unfortunately, we've come to the end of our time. It is a sad, sad moment. But I really do want to thank all of you for joining us this evening. This is one of my favorite times of the month, is doing Science on Tap. It's great to see so many people out here. A few rounds of applause. First, another round of applause for Chapman Crafted for hosting us. Will, thank you. The head honcho just walked in. Will D has been a fantastic partner since we started off over in provisions, and now he's welcomed us into Chapman Crafted. So thank you, Will. Thank you, Panther Productions, for making us look and sound awesome. Sarah Buckley puts this all together. Thank you, Sarah. And we have a very important person to the Grand Challenges Initiative is Ms. Rebecca Green, who makes sure everything works like clockwork. Did Elisa leave us? Elisa, raise your hand. Where's Elisa Hernandez? Elisa is maybe going and refilling her beer, I'm not sure. Elisa Hernandez is a member of the Schmid College team who works with the students to make sure they have awesome internships and awesome job opportunities after they leave. And Grand Challenges Initiative intersects with her work because GCI is all about making the best scholars, the best thinkers, and the best future employees. And so big round of applause for Elisa for all she does for her students. Okay. Does this have next season schedule or next year's schedule on it? Oh, no, it doesn't. Sarah, who's next? Do we remember? I believe you're correct. So, and that's in January? Okay. Hold on a second. We'll get the date because we need to make sure everybody knows. January 14th, here at 6 p.m. Luann Boyd. We just heard about Luann Boyd. Okay, so Luann Boyd works on human-computer interaction. She's a professor of computer science at Chapman University. She works with the Machine Learning Assistive Technology group, and she will be here to talk about how to design software and how to design computer interaction for individuals who think differently, right? So we'll talk a little bit about neurodiversity. So again, thank you everyone for joining us and making this an awesome event. We'll see you in January.